ceramic stick is using degrees. I'm over it. They're so played out. What else can we use to measure angles with? So if you take a look here at question 1, it says a common unit of measurement for length is the inch. What are some other units? What are some other ways that we can measure length? What else do we have other than inches? Go ahead, Remy. Centimeters. What else? Inches, centimeters, what else, Mark? Meters. What else, Karen? Feet. All right, we get the idea. We have miles, yards. So what's different about these units of measurement is, so they're all measuring the same thing. They're measuring distances or measuring length. It's just the actual size of them are different, right? So if we compare the size of a foot, that's a lot bigger than an inch, but they can still be used to measure the same thing. Well, it turns out we have another way that we could measure degrees, and that's what we're going to be exploring today. So first of all, the most common unit of measurement for an angle is what we have been using up until this point, that is degrees. We're going to begin by labeling each sector of this unit circle with the degree measured. So this is just a little review of what we did last week, and it's going to match the degrees that you have labeled on your unit circle in front of you. So let's all right, so with that little wiki stick link, so we're showing that it's exactly the same length as the radius. We're going to go ahead and pick it up now. And starting at the 0 degree position, we're going to shape and stick the piece of wiki stick around the circle. And so we're going to be going in the counterclockwise direction. If I were to kind of draw this out, so if I had like a big life-size wiki stick, it would be something like this. So I'm going to try to kind of use my highlighter to model the path of where your wiki stick is going to be placed, which is what's nice is that you bend a little bit and they kind of stick to your paper. So you can perfectly start back here, stick it along the curved part of your circle, and we want to see how far this goes. And so if you actually have your different colored pen, something that maybe would stand out a little bit more than just a pencil, I'm going to use my red color. We want to actually make a mark here at the end of that distance. And then from that mark, let's actually draw a line directly to the center of the circle. So notice how it's kind of in between the 45 degree and 60 degree position. So it doesn't perfectly line up with one of the lines that we had previously drawn on this circle. Okay, so now what I'm going to have you do is remove your wiki stick piece. Still keep it on your paper, but maybe just set it off to the side here. So go ahead and peel it off. We're going to move it, and I want you to grab your highlighter. And I want you to actually highlight this distance here, just where mine is shown with the yellow highlighter. So there's something very special about this angle that we just measured out and drawn. The angle that's formed when the arc length part of the circle, when the curved part of the circle is equal to the radius length of the circle, it is called 1 radian. So we're going to actually label this here. And a radian is the name, that's the name of the new way that we're going to be measuring angles today. Notice how 1 radian is a lot bigger than 1 degree. 1 degree would be something like teeny tiny, like a teeny tiny little sliver here. So it would be kind of like a centimeter. A radian is much bigger. That would be like a meter. So it's much bigger size, but we're still measuring the same thing. So what interested in now moving forward is seeing how many radians are there one full time around the circle. So it's kind of like with degrees, we have 360 degrees in a circle. We're going to see, well, how many radians are there? So we're going to continue this process. So we're going to grab that little wiki stick piece that I have you set off to the side, and we're going to measure this again. So we're going to start the wiki stick piece right here, right where the last one ended, and we're going to stick it down and just kind of have it follow the curved path of the circle. Again, we're going to make a little mark. You could even draw another line down to the center, so that would be the measure of the 2 radians. And we're going to keep measuring that distance around to see how many we think we can fit all together. And you don't have to alternate colors, but if you happen to have a different color highlighter, or if your partner has a different color than what you have, you could still kind of show the highlighted piece and just kind of switch colors as you move your way around. And this is just kind of approximately how yours should look. I didn't have a big wiki stick here to actually measure it out. But what we should end up seeing is that it looked like the string fit 6 times, but then there was a little bit extra. I'm going to highlight this little extra. So it seems to be like a little more than 6 times to get us all the way around the circle. So what's interesting about that, so let me actually, just going to make a little note here, a little more than 6 radians would be the full distance around the circle. And if you got yours to equal exactly 6, I just want you to try it again. So take your little radian piece and just make sure that you're really careful in where it starts, where the previous one ended, and you should see that you have some little extra. So let's take a look at this halfway point. If we were to look at the 180-degree mark, notice how it's also not exactly 3 at the halfway point. So 3 radians would be right here, that red line on mine, and so we have this little extra here as well. So at the halfway point, it's a little more than 3 radians. This is where we have 180 degrees. Can you think of a number that it might be? Something that is a special number that we use in math that's a little more than 3? What do you think, Sage? Pi. It is exactly pi. It's approximately 3.14 radians at that halfway mark. And actually, today is a special day. It's Pi Day, March 14th. And pi is how many radians we have in the top half of our circle. So if it's pi radians for half of the distance, this little more than 6 radians, that's the full distance around, is actually 2 pi. So that's the whole second half. And 2 pi is approximately 6.2 we get that little more than 6 value. So a couple of things that are special here about this picture is that 1 radian is the angle created when the arc length, the circular part here, is equal to the radius of the circle. And the second thing is that there's 2 pi radians in the full circle. Now we have one more little question down here at the bottom. It says approximately how many degrees does 1 radian angle appear to be? And we're going to actually discover that at the end of this first page here, but it looks like any answer that's maybe a little bit less than 60 degrees, right? So it looks like it's somewhere between 45 and 50, but maybe a little closer to 60. So again, we can see 1 radian is very big compared to the size of 1 degree. All right, so moving into the bottom half here. So we've already answered some of these. So approximately how many times does that radius length piece string stay around the circle? We saw that it was approximately 6 times around, but we did have that little extra. In part 6 here, it says, well, remember that the unit circle has a radius of 1. Well, if we connect that to the formula for the circumference of a circle, we know that circumference is equal to 2 times pi times the radius. Well, since our radius is 1, we can see here that our circumference is 2 pi. So here we're seeing it again. Yeah, that would be the full length of measuring the outside of our circle with a wiki stick. It adds up to a length of 2 pi. So the total amount of wiki stick to get all the way around our circle was 2 pi. All right, now we already know that to go around our full circle, it was 360 degrees. So that's something that we saw last week. So here we're going to put the 2 elements together to figure out exactly how many degrees the angle is from one little piece of the wiki stick. In other words, the angle that we called 1 radian. So we're actually going to write this in the form of what looks like a fraction, where the numerator part represents 1 full distance around the circle in degrees. The denominator is 1 time around the circle in radians. And there's something special here that happens when we divide these. So if we were to do 360 degrees divided by 2 pi, first of all, the way that we would have to type it in our calculator is to put parentheses around the denominator part. If you don't put parentheses around the denominator, what your calculator is going to do is it's going to do 360 divided by 2, and then it's going to take that answer and multiply it by pi. So we want to show that it's divided by both the 2 and the pi, and when we do that, we'll see that it ends up being about 57.3 degrees. So that is the number of degrees that would be equal to 1 radian. And it's kind of like what we just did here to connect the very first fraction to the last one. It's kind of like we just divided them both by 2 pi. So if you look at the denominator part here, 2 pi radians divided by 2 pi is what's turning it into 1 radian. Well, we do the same division on the top, and that gets us down to about 57 degrees. And that seems pretty believable when we think back to where we labeled that 1 radian on our circle. Sure enough, yeah, it was a little less than 60 degrees. So yeah, it was 57.3 degrees. All right, so we really have 2 learning targets for today. So first one was to understand how a radian can be used to measure an angle. So what we're going to start with here is going to look like a definition for radian. So a radian is the angle measure made when the arc length, that's the curved part of our circle, equals the radius length. And we're going to draw a little picture of that here down below. So in our picture, we're going to show like a slice of the circle, a slice of the pie that looked like it was about 1 radian size, so about 57 degrees. And what we were doing here is we were taking this outer circular part, that's our arc length, and then this little piece down here is our radius. So we saw that when these two measurements are equal, see if I can fit this in there, the resultant angle on the inside, that was 1 radian. All right, our second learning target here was to convert angle measures from degrees into radians, and also from radians into degrees. All right, so there's 2 directions here. So if we want to convert from degrees to radians, we're going to take our starting number of degrees, and we're going to multiply that by pi over 180 degrees. So what that is here is this is really a form of 1, because remember the halfway point of our circle was pi radians, or 180 degrees. So technically it's the same thing on the top and bottom, so it's not going to change the value of what we started with, it's just going to change the form. Now let's say we wanted to go the other direction. So if we wanted to convert from radians to degrees, we're going to take our starting number of radians, and we're going to multiply that by the reciprocal of the fraction. We're going to multiply by 180 degrees divided by pi. All right, so in our check for understanding, we are just going to look together at one example for each direction of doing our conversion, and then we're going to finish together by labeling that full circle at the bottom of the page. We're going to label it in degrees, and we're going to learn and see how we can label it in radians. Okay, so for this first conversion, we have a radian measure. Radian measures usually involve the pi symbol. They don't have to, but it's very common. We're going to turn it into degrees. So using that formula that we saw in the box above, this just means that we're going to multiply by 180 degrees over pi. Now this is what helps me to remember what form of the fraction to multiply by, is we don't want it to be in radians anymore. We want to try to get that pi symbol to cancel. And so because we have a pi on the numerator here, we want the fraction that's going to have a pi on the denominator so that we can cancel them out. Now once we've done that, we simply multiply across the top and multiply across the bottom. So all I'm doing across the top here is I'm going to do 3 times 180, and that's 540. And on the bottom, we still have 5. It's kind of like an invisible 1 here. 5 times 1 is still 5. All right. I'm going to go back to my calculator one last time. 540 divided by 5 is 108 degrees. All right, now let's try one going the other direction. So we're going to start here with 54 degrees, and we're going to turn this one into radians. Well, this time, we're going to multiply by the reciprocal of that fraction. We're going to multiply by pi over 180. Now, what I'm thinking about here, although it's not an actual number, it helps me to kind of think about it the same way as I did before. And that is that, this is the same as 54 over 1, by the way. I want to try to get rid of that degree symbol. I want the degree symbol to cancel. So because I have a degree symbol here on that top, I want the other degree symbol to be on the bottom. I'm going to think about getting that canceled out. Now, when we multiply across the top, we get 54 pi. Multiply across the bottom, and we get 180. Now, we actually want to try to simplify the fraction down if we are able to. And you might have to do this a few times until you get the numbers down as far as they can go. I mean, honestly, at the start, they're both even numbers, so you could divide the top and bottom by 2. What I'm actually going to do at the start, what's sticking out to me, is that these are both multiples of 9. So I'm going to divide the top and bottom both by 9, and then I'm noticing, oh hey, they're still even numbers again, so I'm going to go ahead and divide the top and bottom by 2. It might take you a couple steps, and that's fine, but we're going to leave the pi symbol in our answer. We want exact form, so it really turns into 3 pi over 10. All right, I'm going to save these ones here for you to practice and try on your own. You'll also have a chance to try some more of these in your assignment tonight, but we need to make sure that we have some time to talk together about the circle here at the bottom. Now, to also help us save a little bit of time, we have been getting good at labeling our circles in degrees. In fact, we already did that once today. We are going to focus our time now on just labeling the circle in radians. So we are going to see how can we get all of our same unit circle positions labeled a different way. So I'm going to begin sort of in the same way that we have done the others. So just like how we had 0 degrees at the starting position, it could be 0 radians. And if we go one full time around the circle, just like we labeled that as 360 degrees, in radians, it's 2 pi radians. Now, one thing to know about radians is that there's no symbol for a unit, so it's not like the little degree symbol that we use. Radians just don't have a unit at all. Pi is not a unit for radians, it's just commonly used to express radian angles. Let's also label another one that we know all the way over here. We saw earlier that halfway around our circle, it was a little more than 3, so let's go ahead and label that one as pi radians. Now, I'm going to do a little something here to help us think about the top half of our circle. So let's notice here that the top half is divided into sections, but notice how they're not equally sized sections. So what I'm going to do is actually make a little mark here. All of the larger sized sections, I'm going to make a little mark here halfway through. And I'm actually going to add in some dotted lines in an attempt to help us see some equally sized sections here. So it's kind of like that smallest piece that we've labeled that was like worth 15 degrees. It's sort of like we're just going to make a bunch of little segments that are all the same size of 15 degrees. Now, if we just look at the top half, now that we have equally sized sections, let's count out how many we have. From this first section piece here, we've got 1, 2, 3, 4, 5, 6. And then the second part here, 7, 8, 9, 10, 11, 12. We've got 12 sections here on the top half. So when it comes to thinking about labeling this first position, that's technically 1/12 of the way. to get to pi. And so instead of writing 1/12 times pi, what it's really the same as is pi over 12. Or think about taking the full top half of pi, we're dividing it into 12 sections, so the first step is literally pi divided by 12. Well, that's not actually one of our unit circle angles, but it's going to help us to get to the next one. So if this piece here is 1 pi over 12, and we go another piece that's the same size, it's going to get us to 2 pi over 12. So initially here, I'm going to label this as 2 pi over 12, but then we want to reduce the fraction down. So that's really the same thing as 1 pi over 6. But instead of writing a 1 there, I'm just going to write pi over 6. And I'm going to circle that one because that is one of our unit circle angles. All right, now from 2 pi over 12, every time we go one more position, we're just going to add 1 on the numerator. So the next one would be 3 pi over 12. And that's going to simplify down to be pi over 4. 3/12 is the same thing as 1/4. All right, then we have 4 pi over 12, but that's going to simplify down to be pi over 3. Now I'm going to start skipping some of the labels. So I'm only going to label the actual unit circle angle. So this little in-between stop, technically it would be 5 pi over 12. So that the top of our circle is actually 6 pi over 12. And 6 pi over 12 is going to simplify down to be 1 pi over 2. All right, then we have 7 pi over 12. I'm going to skip that label. Our next unit circle angle is 8 pi over 12. And that simplifies down to be 2 pi over 3. After 8 pi over 12, we've got 9 pi over 12. Oh, sorry, my pen is struggling, so I'm going to try to switch to my other pen. This one is going to simplify down to be 3 pi over 4. All right, next one we have 10 pi over 12. That's going to be 5 pi over 6. Okay, after 10 pi over 12 here, technically this would be 11 pi over 12, but we don't need to label that one. After 11 pi over 12, it's 12 pi over 12. Well, that's the same as pi, so that makes sense. This is really 12 pi over 12. After 12 pi over 12, this next spot here would be 13 pi over 12. And so our next label is 14 pi over 12. And that's actually 7 pi over 6. And we've got 15 pi over 12 and 16 pi over 12. So this is going to turn into 5 pi over 4, 4 pi over 3. We are about to run out of time here, but I'm going to have you, there it is. I'm going to have you guys, as part of your assignment, continue working through labeling the rest of your circle. I will also have the correct circle filled in on Schoology if you want to go on and check mine. And the homework for tonight is the same paper.